Hey, everybody at home today. You guys are going to be working on some practice math. And that math is essentially going to be Newton's second law. We're going to introduce Newton's laws next week. But today this week, we're going to be doing balanced and unbalanced forces. And we're going to apply those to the accelerations that we get when we are moving. So, forces causes mass to accelerate. F equals ma. That's our formula that we're going to be using. And we're going to work through a math sheet today. So anyway, I have a very similar math sheet to the one that you guys are going to do, and I'm going to work through the first couple problems here. They're very similar to the first couple problems you have on your sheet. All right, so the first thing we need to do is always rearrange our formula. Whenever we do a math problem, we rearrange our formula first. So we want to know what this formula rearranges to. All right, force causes a mass to accelerate, m times a. In order to get m alone or a alone, we have to do the opposite to whatever we're doing to those letters. So in the equation, we're solving for m. In this, we are multiplying m times a, so we have to do the opposite. We have to divide both sides by a to get m alone. And when I do that, what happens is I get m equals, well, I'm dividing both sides by a, so it's f divided by a. So that's going to be my equation here. M equals f divided by a. If I want to solve for a, I'm going to divide both sides by m. So m divided by m equals 1. The m goes away on that side, but I divide it on the other side as well, and I get f divided by m. So force stays on top here. Mass is force divided by acceleration, and acceleration is force divided by mass. So let's see how this applies in real life. All right, I have a bike, and a biker has a total mass of 50 kilograms. If he pedals with a force of 110 newtons and encounters a 10 Newton frictional force, what would their acceleration be? All right, remember from last week's lab, friction opposes motion. So I'm pedaling with 110 newtons, but 10 newtons of frictional force is opposing me. That means my total net force is going to be 100 newtons. So I have 100 newtons of net force. I get that from 110 forward, 10 back. They cancel each other out to the course of 10 newtons, so I get 100 newtons of push. My acceleration is what I'm solving for. My mass is going to be 50 kilograms. So I know I'm solving for acceleration, which I know is acceleration equals f divided by m. I go ahead and work this out. So I get acceleration equals 100 newtons divided by 50 kilograms. And therefore, I get an acceleration of 2 newtons per kilogram. Now, I want to take a pause for a second here, because newtons per kilogram doesn't really make sense for an acceleration. But I know that a newton is found by multiplying mass times acceleration. So it's going to be kilograms, meters per second per second. Mass is in kilograms. Acceleration is in meters per second per second. And I'm dividing that by kilograms. So when I divide those out, I actually get acceleration equals 2, the kilograms cancel, 2 meters per second, which is a much more familiar term for acceleration. It's the increase in speed because you're getting pushed. When you push, you increase your speed. It's going to be 2 meters per second. So that's the first problem. Let's get this on its own page here. Second problem, a bike racer accelerates at a rate of 5 meters per second. And they have a total mass of 100 kilograms. This time we have to find the force. This one's easy. F equals ma. F equals 100 kilograms times 5 meters per second. And that's going to yield an answer here of F equals 500 kilograms times meters per second, which, as we said in the last one, a kilogram meter per second is going to be, pardon, I should have put a 5, should be 500 newtons. So there's my answer there. All right, last one here. A bike rider generates a net force of 200 newtons. If we have a mass of 50 kilograms, what will the acceleration be? All right, this time we're solving for acceleration. So we know that acceleration equals force divided by mass. So acceleration here equals 200 newtons divided by 50 kilograms is going to be an acceleration equals 4. And then again, it's newtons per kilogram. But as we know, when we divide that out, acceleration equals 4 kilograms meters per second divided by kilograms, which is going to be acceleration equals 4 meters per second. And there you go. So that's how you do the math problems today. I have a separate sheet for you guys at home that'll walk you through that. And if you have any problems, I will be on the Meet through class and you can pop on in. So thanks very much.